All right, so we're evaluating basic trig functions in radians. We're going to find the exact value of cosine of pi over 4, expressing your answer with a rational denominator. So pi over 4, then you go over here, you look at the unit circle. So just to remind you, in all of these coordinates on the unit circle, you have cosine first, cosine of theta, remember theta is your angle, comma, sine of theta, let me write please, there we go. So if we're looking for cosine of pi over 4, then what you do is you look for pi over 4. I'm going to use a different color so it's not all like bland. Here's the pi over 4 angle. You just look for it on the unit circle. And then you take note of this coordinate dot. And then let's take a look at what it says as our x and y values. Remember that cosine specifically is the x value. So we're going to completely ignore the y value. And we're going to just take a look at this. Root 2 over 2 is cosine of pi over 4. So if they're asking for the cosine, you look for the x value. If they're asking for the sine, you look for the y value. I know this is just the first example, but right now, do you guys have any questions? Okay, then I'm going to type this in. Root 2 over, nope, that's not how I want it. Okay. I'm just like, it's in the way. Okay, sorry, unit circle. Go away. You know what? I don't know how to do this. Go away. Oh my gosh. That's so much better. Okay. Okay, sorry. Let's do this properly now. Root 2 over 2. There we go. Submit. Yes, submit. And let it load. Next problem. Okay, find the exact value of tangent of pi over 3. Let's screenshot this one again. Okay, so in case you forgot like what tangent is, let me remind you that, let me write this in blue. Tangent, can you see where I'm writing? I'm writing on the delta math section. Tangent of theta, tangent of your angle, is equal to sine of your angle over cosine of your angle. Okay? Sine over cosine is tangent. In other words, remember that since the x and y are cosine, cosine, sine, then tangent is equal to y over x. Pausing here, do you guys have any questions? That tangent is y over x. Put a box over that. Okay, you guys didn't say anything, but remember, if you have a question, please interrupt me. So we're looking for a tangent of pi over 3. That's what it says. So let's look for the pi over 3 angle. Normally I'd have somebody point at it, but you guys can't point on my computer. So here you go, here's the pi over 3 angle. Notice the dot, that coordinate is 1/2 comma root 3 over 2. So I'm just gonna point to it so you guys can see that's the coordinate we're looking with. So remember that tangent is y over x. So let's first note our y value, which is root 3 over 2. And then put our x value on the bottom, which is 1/2. Okay, I got a question. Let me check the question. How did I get pi over 3? Or how did I choose that one? Okay, look at the question. Find the exact value of tangent of pi over 3. So they're asking for pi over 3. So I'm looking for the angle where it says pi over 3. Does that make sense? Okay, cool. Yes, you're welcome. So yeah, whatever angle they tell you to find the sine, cosine, or tangent of, that's the angle that you're going to look for in the unit circle. Okay, so we found the pi over 3. We put the y over x because this is our tangent. And then now we just need to simplify this mess of a fraction. So it's root 3 over 2, and then it's 1 over 2. Since both the numerator and denominator have a over 2, you can just ignore the over 2. In other words, we're multiplying the top and bottom by 2. So let's just cancel it out. So we get root 3, sorry, that's really messy, root 3 over 1, which in other words is root 3. So whenever you have the fraction over the fraction, in the case of the unit circle, since all of our fractions are over 2, you can just cross out the over 2's, okay? They can cancel each other out. That's for the unit circle. So since every fraction in the unit circle, look at them all, they're all over 2, you can just cancel out the over 2. So then it makes your fraction look more simplifiable, makes it look neater. So now we simplify to root 3 over 1, which simplifies just to root 3. And so that is our answer. So now, before I type this in, do you guys have any questions?
I have a question.
Yes.
So for cosine, you just like go to the table, and then for tangent, you have to like actually work it out.
Yeah, so for sine and cosine, you literally just look at the unit circle and read like x value for cosine, y value for sine. You literally just read it and type it in. But for tangent, then you have to do some fraction.
Okay,
Yeah.
thank you.
Good question. So does anyone else have a question? Okay. Make sure you interrupt me if you come up with a question, okay? So I'm just going to enter this in to be a root 3. Come on, load, please. All right, let's go to another problem. I just want to see if I can get another tangent problem, because the tangent ones are harder. You literally have to calculate something. I'm gonna come up with my own problem to show you guys. So what if we have tangent of pi over 6? I'm just gonna write out this problem for you guys, okay? So ignore this one. We're not doing this problem. Oh, you know what? We can do something similar. Tangent of pi over 6. So I'm not doing the problem they're giving me. I'm giving you a third example. That's just my own example, okay? So my example is tangent of pi over 6. And it's just because I want you to know how to simplify this type of fraction. Okay, so let's look for pi over 6. I found it. Here's pi over 6. So it's this angle. That one. Anyways, so then we look at the x and y. Remember that tangent is the y over x. Write this down if you haven't already. Tangent is the y over x, okay? So cosine is the x, sine is the y, tangent is the y over x. Okay, so then we have our 1/2 over root 3. Let me write these, root 3 over 2. There we go. And then I said we can cancel out the over 2's because everything's over 2, then they just cancel each other out. You get 1 over root 3. Okay, so here's the thing about this specific type of fraction. When you have a square root on the bottom, you have a radical on the bottom. That's not mathematically correct, as in like it's incorrect grammar. Okay, like there's a grammar to math. This is incorrect grammar. So what you need to do when you have the radical on the bottom is multiply the top and the bottom by that same radical. So if it's 1 over root 3, then I multiply top and bottom by root 3. So write this down if you don't remember this, which is probably a lot of you because we haven't been in school for 7 months, right? Okay, so then multiply the top across. 1 times root 3 is just root 3. And on the bottom, root 3 times root 3, that actually gives us 3. So then our 1 over root 3 has now become a root 3 over 3. So does anyone have a question on that? Or anything here?
I have a question.
Yes.
So radical 3 times radical 3. So any number that's a radical times itself, would that just come out to like just a number?
Yeah, so the radical 3 times radical 3 is the same thing as radical 3 squared, right? Like, because when you square it, it's times itself. And then the radical and the squared are like opposites of each other, so they get to cancel out. And then you're just left with 3.
Okay.
Yeah.
Thank you.
You're welcome. And then okay, so several people asked about the 3 on the bottom, so you verbally asked that. Does that help the other 2 people? Yes, okay. And then somebody else asked about the radical 3. How did I get the radical 3 over 3? Oh, okay, so to answer that question, like how did I get to this answer? I can't point, so I'm just highlighting it again. How did I get to that? Well, we had the 1 over root 3, right? The step before it. And I told you that's incorrect math grammar. So in order to get it to be correct, what you have to do is multiply. So you have to multiply the top and the bottom by the radical. So I multiplied the top by root 3. I multiplied the bottom by root 3. So 1 times root 3 gives us just root 3. So that's how you get the root 3 on the top. And then we went over the bottom was root 3 times root 3 is root 3 squared. And the root and the square cancel out, so you just get a 3 on the bottom. So, okay, cool. Does anyone else have questions as well? Or does anyone have any other questions? Okay, make sure you interrupt me if you do have a question. I'm not going to enter this into Delta Math because I did a totally different problem than what they wanted, but you guys still got 3 examples. Hopefully the others can be straightforward for you as well. Also, please know that sometimes your sines and cosines and tangents can be negative. Like if you look at the unit circle, some of the coordinates are negative. So if you get a problem that's negative, and you're doubting yourself, yes, negative is possible, okay? So let me go to the next section.